Good day, viewers. This is 300 Plus Academy, where all we do is exams tutoring, ensuring that you ace your next exam. Still on chemistry, what we'll be looking at is mass, what we call mass volume relationship, talking about molar volume. When we talk about the molar volume of a gas, if I have 1 mole of oxygen, you need to know that the space that 1 mole of oxygen is going to occupy is 22.4 dm cube, or you say 22.4 liters. Similarly, okay, let's say, okay, for oxygen gas here, if I have 1 mole of propane gas, C3H8, this is going to occupy 22.4 liters. So it does not matter the gas. So long as it is 1 mole, it is going to occupy 22.4 liters. This 22.4 liters is what we call gas molar volume. So the molar volume is talking about the space occupied by 1 mole of a gas, and that is 22.4 liters. Now, recall that under mole concept and stoichiometry, we've said that mole equals to mass over molar mass. When we're talking about gaseous reactants and products, when we say the mole is the volume of a gas compared to the space occupied by 1 mole of that gas, and that is molar volume divided by molar volume. Molar volume is the space occupied by 1 mole of a gas. So where mole for solid reactant, liquid reactant, you're talking mole equals to mass divided by the molar mass of 1 mole. For gaseous reactant, we say mole equals to volume compared to the volume of 1 mole of that gas. Mole equals to mole. The meaning is we can say mass over molar mass equals to volume over molar volume. This is the link between mass and volume, and that's what we mean by mass volume relationship. Okay, let's move into solving question. For the first question here, it says calculate the volume occupied. We're looking at for volume occupied by 0.4 mole of a gas. Okay, the mole of the gas here is 0.4 mole at STP. Very simple. We know that mole equals to volume over molar volume. So if I'm looking for volume equals to mole times molar volume. In this case, the mole is 0.4 times gas molar volume is 22.4 dm cube. 0.4 times 22.4 equals 8.96 dm cube, or you say 8.96 liter. Moving on to the next question, question 2. It says what volume will be occupied by 6 grams of nitrogen gas? We're looking for volume will be occupied, then we're given mass of nitrogen gas to be 6 grams. This is pretty direct. When you're talking about nitrogen, that's N2. The molecular mass here is going to be 14 times 2, and that's 28. Okay, that said, for question 2, we were told to look for the volume. What volume will be occupied by 6 grams of nitrogen gas? In this case, that is mass volume relationship. Volume over molar volume equals to mass over molar mass. Okay, this is going to mean, what is the volume? I'm looking for the volume. The molar volume here is 22.4 dm cube equals to the mass here is 6 divided by 28. This moves here, so volume equals to 6 times 22.4 divided by 28. Therefore, the volume will be equal to 4.8 dm cube. That is the answer. Look at the question very well. You were told to look for volume given the mass of nitrogen. So this is a case of converting mass to volume, talking about mass volume relationship. Okay, let's move to question 3. Question 3 states what mass of CO2 will be formed in 1.12 dm cube of it. It means the volume is 1.12 dm cube. So we're told what mass will be formed. in 1.12 dm cube of it. This is still mass volume relationship. You have volume, you want to know the mass of this. So mass over molar mass equals to volume over molar volume. The mass here is what we're looking for. Molar mass of CO2 is 44. If you calculate CO2, that will give you 44. Equals to what is the volume? 1.12 dm cube divided by 22.4 dm cube. This off. So the mass is going to be 1.12 times 44 divided by 22.4, and that way the mass is going to be 2.2 gram. Yes, this is going to be 2.2 grams. So that ends question 3. Moving on to question 4. Question 4 states, find the volume of oxygen that will be formed. We're looking for a volume of oxygen that will be formed 4.25 gram, okay? The mass of potassium triacylchlorate 5 here is actually 2.45 gram of potassium triacylchlorate 5 were decomposed by 8. Okay, let's look at this. This is potassium triacylchlorate 5, okay? This will give us KCl plus oxygen gas. In a B2 balance, this will be 2, this will be 3, and this will be 2. So I am looking for the volume of this, okay? When 2.45 gram of potassium triacylchlorate 5 were decomposed, in this case, this is just stoichiometry, but looking at converting mass to volume. Talking about potassium triacylchlorate 5, the mass of this is 2.45 gram, okay? And we just have to use stoichiometry here, talking about something we've treated before, Kiddo concept, talking about stoichiometric equivalent. So what this means is that this is my key. Mole of this is going to be 2.45. The molar mass of potassium triacylchlorate 5 is 122.5 when we calculate for this. So the mole here is going to be 0.02 mole. So looking at this, 2 mole of potassium triacylchlorate 5 is stoichiometrically equivalent to 3 mole of oxygen. So 2 moles of KClO3 is stoichiometrically equivalent to 3 mole of oxygen. So 2/3, that's 2 represents from equation the mole of KClO3 compared to 3 moles of oxygen from the equation, and the implication of that is 0.02 mole divided by what will be the mole of oxygen. Mole of oxygen here is going to be 3 times 0.02 mole divided by 2, and this will give you 0.03 mole. Okay, now this is the mole we need to convert to the volume of oxygen here. Recall that mole equals to volume over molar volume. Therefore, volume equals to mole times molar volume. The mole of oxygen here is 0.03 times 22.4 dm cube, and that way we're going to get 0.672 dm cube. You leave your answer this way, or 672 cm cube if you multiply by 1000. So that is the volume of oxygen there. Look at it very well. In this case, you have to write balanced equation, and when you write balanced equation, you have to equate it, and when you equate it to get the mole of oxygen, when you get the mole of oxygen, you convert it to volume. So that ends question 4. We have the 5th question. One mass of lead-2 triazonitrate 5 solid. That is why for a science student, it is very important to know how to, write the formulas of your compound. Some of us, we don't know how to, so that's a business for another day. One mass of lead-2 triazonitrate 5. This is lead-2 triazonitrate 5 actually. Okay, 1 mass of lead-2 triazonitrate 5 solid would be heated to obtain 11.2 dm cube of brown nitrogen peroxide. So when we eat this, this is what we're going to have: lead oxide plus nitrogen peroxide, and take note, oxygen is going to be liberated in this process, so that what we have here, in a bit to balance this, this not looking balanced, I have 2 here. Okay, okay, if I put 2 here, this makes this 2BO, and then, you know, because this is already even 2 times 3 6, if I don't put 2 here, that makes this odd. So I have to just, that's the starting point. I decided to put 2 here, and since I put 2 here, the lead, okay, I have to put 2 here. So when I look at it, 2 times 3 times 2, that makes it 12 oxygen. For now, I have 2 oxygen here. 2 nitrogen times 2 nitrogen, that's 4 nitrogen. Okay, I think that's just about it. 2 oxygen here, 8 oxygen here, that's 10 plus 2, 12 oxygen. This is a balanced equation. So in this case, the brown nitrogen peroxide, is the volume here is 11.2 dmq, and we were told to look for the mass of lead 2 triazonitrate 5. This is just a case of Kiddo concept. So when I look at this, I have to convert this to mole. So mole of this is going to be, mole here is going to be volume over molar volume, and in this case, this is 11.2 divided by 22.4. This is going to give us 0.5 mole. Okay, so 4 moles of nitrogen, 4 moles of nitrogen peroxide is equivalent to 2 mole of lead 2 triazonitrate 5. So if I'm saying 4 over 2, it means 4 divided by 2, then mole of this 0.5 mole divided by mole of lead 2 triazonitrate 5. So mole of lead 2 triazonitrate 5 will be 2 times 0.5 divided by 4, and this is going to give us 0.25 mole. 0.25 mole. Since I am looking for the mass, I am looking for the mass of lead triazonitrate 5. So the mass of lead triazonitrate 5, recall that mole equals to mass over molar mass. So the mass will be what? Mole times molar mass. What is the mole there? 0.25 mole times, what is the molar mass of lead triazonitrate 5? If you look at it, Pb equals to 207 triazonitrate 5. N here, NO3. NO3, this is 14. 16 times 3, this is 48. 14 plus 48, that is 62. 62 times 2, that is 124. So 207 plus 124, 207 plus 124, that is 331. So 0.25 times 331, that will give us 82.75 gram. That is the mass of lead triazonitrate 5 needed to produce this. Look at it very well. I'm going to convert this to mole. I'm going to write the balance equation, convert the key to mole. I use this mole to unlock the mole of this, which I got 0.25. To get the mass of this, that's going to be mole times the molar mass. The molar mass of this is 331. In case, for those who don't know how to calculate relative molecular mass, we've had that lecture before. Just check out the channel 300 plus academy, and look for the topic on, of course, that will be in the description. I'll put that in the description, and as well you can search for the lecture on relative molecular mass, and you'd be good. So that ends question 5. Moving on to question 6. 1.78 gram of ammonia gas were decomposed completely. We're looking at the composition of ammonia gas here, okay? The composition of ammonia gas will give us nitrogen gas plus hydrogen gas. In a bit to balance this, because I'm having 3 here, if I put 3 here, I'll need to put 2 here, and you know, this just gives us a balanced equation here. 1.78 gram of ammonia gas, so the mass of this is 1.78 gram of ammonia gas. We decompose completely into nitrogen and hydrogen. Calculate the volume of the resulting gas measured at STP. Volume of the resulting gas talks about volume of nitrogen, volume of hydrogen. What is the volume of this? What is the volume of this? Okay, this is my key, so I can convert this. In a bit to convert this to mole, the mole of this is mass over molar mass. This will be 1.78. Ammonia gas, if you calculate it, that the molar mass, ammonia gas, the molar mass is 17. That the mole of this is 0.105 mole, 0.105 mole. So we then use this to unlock this. Dealing with the nitrogen first. Okay, let me deal with the nitrogen this way. This means 2 mole ammonia is equivalent to 1 mole nitrogen. So 2 over 1. 2 over 1 will mean, what is the mole here? 0.105 divided by mole of nitrogen. So that mole of nitrogen equals to 0.105 divided by 2. Mole of nitrogen will be 0.052 mole. So since I'm looking for the volume, you recall that mole equals to volume over molar volume. So volume here is going to be mole times molar volume. So this is 0.052 times 22.4. That should be 1.165 dm cube. That is the volume of nitrogen. If I am to deal with hydrogen gas here, I'll be saying 2 mole of ammonia gas is equivalent to 3 mole of hydrogen gas. So in this case, 2 over 3 will mean 0.105 mole divided by the mole of hydrogen gas. So mole of hydrogen gas is going to be 3 times 0.105 divided by 2. Mole of hydrogen is going to be 0.156 mole. Okay, that is the mole of hydrogen. So the volume of hydrogen here is going to be mole times 22.4. So the mole here is 0.156 times 22.4. So 3.53 dm cube. That is how this is to be dealt with. And you can see, calculate the volume of the resulting gas measured at STP. This is just a case of stoichiometry, and when we do this, that's for question 6, would be good. So that ends question 6. Moving on to the last question, talking about impure marble. 32.4 grams of impure marble were treated with SS hydrochloric acid. Okay, so we have marble. When we say marble here, it talks about calcium trisulcarbonate 4. But you said impure. So whatever is impure we don't use the mass of the impure substance here is 32.4 grams. But because it is impure, we cannot use this in our stoichiometric equation here. Anything that is impure, we don't use it. That was why we had lectures on Kiddo concept talking about stoichiometry, before we got to this level. Or the link to that lecture video on stoichiometry will be in the description of this lecture. So 32.4 grams of impure marble were treated with SS hydrochloric acid. plus HCl aqueous. But for the HCl, we were told that the concentration is 7.01 dm³. Okay, once we have this, this will react with this. Okay, I'm going to be talking about calcium chloride, CaCl2. Okay, and water is going to be formed, H2O, and of course carbon dioxide gas will be liberated. So in a bit to balance this, this is going to be 2, and this is just a balance equation, CaCl2, H2O, CO2 gas. In this case, we were told that the carbon dioxide, 7.0, not the concentration of HCl, 7.01 dm³ of this gas, 7.01 dm³. That is the volume of carbon dioxide liberated. This is not pure, this is pure. The implication of this is that this is my key. This is what I can convert to mole. So mole of this is going to be volume over molar volume, and this is 7.01 divided by 22.4, 0.313 dm³. Okay, what this means is 1 mole of CO2 is equivalent to 1 mole of calcium triazocarbonate 4. This is a mole. The mole of this 0.313 mole. So 1 mole CO2 is equivalent to 1 mole CaCO3. So the mole of calcium triazocarbonate 4 here is going to be 0.313 mole. And that said, now the mass of calcium triazocarbonate 4 here is going to be mole times molar mass, and that means 0.313 mole times molar mass of calcium triazocarbonate 4 is 100. So this will give us 31.3 gram. That is the mass of calcium triazocarbonate 4 that took part in this reaction. So in the question, we were told to calculate the percentage purity of marble. Percentage purity of the marble is going to be, what is the mass of the pure substance divided by the mass of impure substance times 100. In this case, that is, the percentage purity is 31.3 divided by out of 32.4 times 100. This will give us 96.6%. So that is the answer there. You see, stoichiometry, mole concept, and Avogadro's number, they are not things we can play with as we prepare for UTME. They are things you take serious. Take note of your mole concept and Avogadro's number, stoichiometry 1, stoichiometry 2, talking about Kidal concept, and what we call limiting and excess reactant. You can't wish them away. You cannot wish them away. They are part of what you need to expect in your exam. But with that, we've come to the end of this lectures. If you have any concern about any of this, all you need to do is very simple. Just hit the comment section and drop your comment, or better still, visit us at 300plusacademy.com. Link up with us on WhatsApp and DM any of the admin. We'll be glad to attend to any of your questions, views, comments, and all of that. Also, do not forget, hit the subscribe button, turn on the notification bell, and I tell you, share with your friends. They're going to be glad you did that for them. From myself and the entire team, it's bye for now.